Yay, you've made it to the last podcast. Congratulations of this unit. Marvelous. We're going to talk about the average atomic mass tonight. Not long, but something that is very mathematical. You need to know how to do this. Let's think about the average age in our class. So, do you know how to determine the average age of the class? Could you estimate it? What do you think it is? Well, did you happen to remember that I'm in the class too? Let's say there are 20 people in the class, and that one is 15, 14 or 16, 4 is 17, and 1 is 56. That's me. Okay? Question is, what's the average? Think about that for a second. Pause the video if you need to. Come up with a number. All right, well, you might have come up with the number 36, because 36 is halfway between 16 and 56. That's not right. Why is that not right? Well, the reason that's not right is as you think of our classroom, most of you are students. And then there's one outlier. That's me. All right? So bottom line is most of you are teenagers. So that means that our answer is probably going to be somewhere between, let's say 16 up to 20. Somewhere in that range. It's not going to be higher than 20 because most of you are teenagers. Okay? So let's see what happens. How would we actually do this? Well, the way we would do this is that you'd look at, I have a total of 20 people. Right? So 1 over 20 is 5%, which is 0.05. And 14 over 20 is 70%. Stop that. Which is 0.70. And 4 or 17, 4 out of 20 is, let's see, 20%. So that's 0.2. And 1 out of 20, we've already done that. That's 0.05. Now those numbers should all add up to 100%. And they all add up to a total of 1 when you add them up. So that's good. Now, 5% of our people are 15 years old. 70% are 16 years old. 20% are 17 years old. And one of us, me, is 56. Okay, so let's see. 10% of 15 would be 1.5. So that means this is 0.75. And let's see, 16, 70%. Well, 7 times 16, 7 times 1.6. 7 times 1.6 is 11.2. And we have 0.2 times 17, so 0.1 times 17 is 1.7. So that would mean this is 3.4. And 1% of 56 would be, 10% would be 56. So 5.6, so half of that would be 2.5, 2.8. Okay, 2.8. So if I add all those things together, right, I get 18.15, and that's not legal because I have too many sig figs there. So I'm going to make that 18.2. So my average age is 18.2 years old. All right, so what did I do? Let's stop for just a second and analyze what I just did. I looked at the ages that I had for every person. Right? And what I did was I looked at the percentages that I had. The percent that were 15, 16, 17, and 56. I multiplied the percentage by the age, and I came up with a number. And I added all those numbers together to come up with my final answer. So, let's go see if we can do that. But this time we're going to do it with elements. All right. So the atomic mass is actually a weighted average, so it should be called the average atomic mass. And it's the weighted average of all of the isotopes of an element that exists in nature. So clearly if I look at chlorine, chlorine must have multiple isotopes because I can't have half of a neutron. On the other hand, when I look at technetium, we talked about this one in our last podcast, the technetium only has one isotope because it's man-made. Okay. So chlorine has multiple isotopes. So how do we figure out what its average, weighted average is? Well, we have to be given information. So to be able to calculate the weighted average, we have to be able to figure out what the percentages of each of the isotopes of that element. Okay, so we have to look at the fractional or percentage abundance of the individual isotopes. So we have to be given that information. This isn't something that you just make up. We have to figure it out by experimentation. Okay? So let's actually look at some information that we have. We have specifically isotopes of silicon. And we have 3 different isotopes we're going to be looking at. Silicon always has 14 protons, but in this case, we have a mass number of 28, 29, and 30, which means here we have 14 neutrons, here we have 15 neutrons, and here we have 16 neutrons. Right? So these are all isotopes of silicon. But as we look over here, we'll notice that for percent abundance, we can see that the majority of the silicon is silicon 28, which weighs, when you actually get out there and measure it precisely, it's 27.977. So how do we actually figure out what our average atomic mass is? Well, we're going to take our mass amount, and we're going to multiply it by our percent abundance. So let's just write this down, right? And if you need to, pause the video and write it down. But it should be 27. Sorry, my pen's acting up again. 27.977. And we're going to multiply that by 0.9221. Remember, you have to move the decimal point because we're working with percentages. We're going to take 28.976. And we're going to multiply that by 0.0470. And we're going to take the last one, which is 29.974. We're going to multiply that by 0.0309. You're going to come up with answers here for each of these. And when you're all done, you're going to add them up. So, I've actually done that on the next page. So, I take these numbers, I multiply them out, I come out with totals over here on the right. I add them all together, and I get 28.09 atomic mass units. So this is the atomic mass of silicon to 2 decimal places. Why to 2 decimal places? Well, because when I'm adding numbers, you'll notice I have 2 digits, 2 digits, 3 digits. Oops, can't use that one. Okay, so I'm going to have to round it. But anyway, this mass takes into account all of the isotopes of silicon with respect to the percentage of the isotope that's found in nature. And this is the way we come up with an average atomic mass. So, you try one, right? So you can just assume that chlorine weighs 35 and this chlorine has a mass number of 37. Okay? Pause the video, go ahead and do it, and then come back and I'll do it with you. Okay, we have a mass of the first isotope of 35. Mass of the second isotope of 37 atomic mass units. Now our top one is a percent abundance of 77.35, or 0.7735 is a decimal. Your second one is going to be 1 minus that number, which is 0.2265. I'm going to come up with 2 numbers, and when I do these, I come up with 27.0725, and I come up with 8. Now you'll notice, guys, I'm using a lot of sig figs here, right? That's okay. Right? I am assuming that the 35 and 37 are pure numbers. They're not measurements, right? Which is an incorrect assumption, but we're going to make it anyway. So when we add these up, we are going to come up with 35.453, or 35. So 35.45. So bottom line is, that's what we came up with for our average atomic mass. This is the way you come up with average atomic masses and weighted averages. You clearly need to be able to do this. So, it's your turn. Go off and do the atomic mass worksheet. Go back and take notes if you forgot to take them on the podcast so you know how to do this. And ask for help if you need it. And then you can go take your test. Enjoy your afternoon. We'll see you soon. Bye.